Hopefully you've had a chance to try this practice problem out. I'm going to walk through the solutions now. So if you haven't, just pause and give it a try. So in this one, we're looking at a dimer. The R is like a variable. It's saying there's this big chunk of molecule that doesn't actually do very much in the actual reaction. It's all happening at that interesting iron atom and the oxygen atom. Um, and it just abbreviates it, so it's not quite such a big thing to write out. So we have this dimer. It's got some iron in it, and it reacts with hydrochloric acid, and it forms hydrogen gas when it does this. So we have something like the dimer plus our hydrochloric acid, and it's producing some hydrogen gas. At least we know that. So we are measuring how much of this hydrogen evolves. So we're measuring this, and that's giving us rates of reactions. So we're seeing how much that product evolves. And so we do 3 trials or 3 experiments, and we're going to vary the concentrations. In trials 1 and 2, we look at the difference between the concentrations of the dimer. And in trials 3 and 2, we're looking at the difference in the concentration of the HCl. So what we're going to do is develop a rate law. That's our first question. It's like, what's the rate law? So we're going to need to figure out the order with respect to each of these reactants. And then we're going to have to find the rate law constant as well and write it all out. So we'll do that first. Then we'll look at the overall order of the reaction, the order with respect to hydrochloric acid, the rate constant, which will be part of our rate law. And we'll also look at what happens when we'll predict how much hydrogen will form in 60 seconds. So a lot of these B through D are going to be really answered as we develop our rate law. So let's get started. Let's start by looking at the dimer concentration. So first I'm going to find the order with respect to the dimer. And to do that, I'm going to be taking the rate law essentially for this whole reaction and filling in the information I can. Just a reminder, our basic rate law is going to look like. All right, so let's find that value of M first. So what is M? All right, so we're going to look at trials 2 and 1. And I like starting with the higher concentration on the top. So I'm going to look at the rate of trial 1 over the rate of trial 2. It's going to be equal to the equilibrium constant of, so we'll do K. And so our concentration for our iron dimer is going to be 5 molar to the M, and our hydrochloric acid is going to be 10 molar to the N. For our rate 2, that's going to be looking at the K for our for our rate law constant. And we're going to be looking at 2.5 molar now for number 2 for M. And the concentration of our hydrochloric acid doesn't change. So looking at this, we are going to have our 3.00 times 10 to the negative 3 for our rate divided by 1.5 times 10 to the negative 3. It's going to give me a value of 2. And a lot of this stuff in my rate law cancels out, like these K's cancel out and everything for our hydrochloric acid cancels out. So it's going to be 2 is equal to this 5 divided by 2.5 molar to the power of M. And so this is going to be equal to 2 is equal to 2 to the M. So if I take the log of both sides, then I'm going to have M is equal to the log of 2 divided by the log of 2, which will be equal to 1. So my order with respect to the dimer is going to be 1. All right, so that's part of it. Now we got to go ahead and figure out the order with respect to the hydrochloric acid. Now I can go through this exact same process, or I can notice something. When I look at what happens when I change my hydrochloric acid and look at the rate, I can see that the rate does not change. And there's only one way that'll happen. It means that the order has to be equal to 0. So at this point, I can walk through the same calculation, or I can just say that it's 0 because it doesn't change. All right, so I have my orders. Now I can figure out what the rate constant is, and that'll allow me to write out my whole rate law. So I'm going to go ahead and just use the first one. So let's figure out what K is. So I'm going to use trial 1. You can use any of the other ones that you like. It doesn't really matter. So that's going to be equal to my rate is 3.00 times 10 to the negative 3 molarity per second is equal to this rate constant that I'm going to solve for times my concentration of dimer, which is 5 molar, and that will be to the power of 1. And then my concentration is 10 molar for my hydrochloric acid, but it's to a power of 0. So this is going to equal 1 no matter what. So you can leave that part out if you want. And I'm going to solve for K. K is going to be equal to 3.00 times 10 to the negative 3 divided by 5 molar. And that's going to give me a value of 6 times 10 to the negative 4th. And it's going to now have units that match its overall order. So we need to check that overall order to be able to figure out its units. So my overall order is going to be equal to the sum of the exponents, which is equal to 0 plus 1, which will be equal to 1 overall. So that will then inform the units of K. So I will have units that are inverse seconds, or 1 over seconds to the negative 1, or seconds. Sorry, or s to the negative 1, either way. All right, so now I can write out my whole rate law. So my rate law is going to be equal to the rate, or it will be, the rate is equal to K, which is 6 times 10 to the negative 4th seconds to the negative 1, or 1 divided by seconds. So there's my K. The concentration of my dimer, and that'll be to the power of 1. And I can include the HCl to the power of 0, or I can leave it off because it'll be 1 no matter what. And that is my rate law. Answering a few other questions here. So that's my rate law. The overall order of the reaction we learned was 1. Let's see, our other question is asking, what's the order with respect to hydrochloric acid? So the order with respect to hydrochloric acid concentration is 0. Our rate constant, which is K, was equal to 6 times 10 to the negative 4th inverse seconds